Okay, so here we're reviewing the trig unit in Math 10C, so grade 10 math in Alberta. Starting off with just understanding SOHCAHTOA, so when to use which ratio. So this is already starting with that we know what a right triangle is and that you can label your sides. So if I'm starting and taking a look at my triangle, it is saying this at angle X in degrees, but the question's not asking that. It's asking what's the cosine of F. So F's angle is here, and if you're doing cosine, you're looking at the adjacent side and the hypotenuse side. So from angle F, you have the opposite side, the adjacent side, and of course, always across from your right angle is your hypotenuse. So if I'm setting up my trig ratio, so cos of F equals adjacent over hypotenuse, I'm just going to replace those values. So 8 over 17, and this can't reduce, so here your answer was B. Moving on from there, now you're asked to solve for X, and if I wanted to solve for X, I would start with naming my sides from this point here, and I need to see which one will work out. So from X and not F, my opposite and my adjacent side change, but your hypotenuse never does. So when we're looking at this area, you need to set up a ratio, and it's always with the sides you have. And we have all sides. So we could use SOHCAHTOA. We could use any ratio because we have all three sides. So if we're doing that, just pick one. I'm going to go with sine. Sine of angle X will equal the opposite side, which is 8, over the hypotenuse, which is 15, right? Opposite over hypotenuse. So when you actually want to calculate this value, you'd have to, in your calculator, if you're finding an angle, you would hit second first and then the sine button. If a bracket automatically opens up, then you're fine. If not, because we are going to be dividing, open a bracket and then divide. When we do this, and if you do it correctly, you'll see that the angle equals 28 degrees. Now, moving on from here, the next part of this question is saying which statement is false. So if we are taking a look, and just again, it depends where we're starting from. If I wanted the cosine of E, cosine is adjacent over hypotenuse. So starting from E, what's labeled, you have the adjacent side, so 15 over the hypotenuse. And we want to know if that will equal the sine of F. If I start from F and I'm looking at sine, it's opposite over hypotenuse. So opposite to F is the value 15, and we're still going over 17 here because that's the hypotenuse. So this one is true, but it's not asking that. It's asking which one is false. So I'm just going to skip to the answer because I know it. And the answer is C. So let's just show why. So if I want the tan of E, tan is opposite over adjacent. So if I start at the angle E, which is angle X here, opposite is 8, adjacent is 15, hypotenuse is 17. So the tan of E would be opposite over adjacent, so 8 over 15, and it's saying that equals the tan of F. If I was at F, 15 is my opposite side and 8 is my adjacent side. So that would be 15 over 8. That's why this one is not true, because if it was true, both sides you'd see the same thing. So sorry that this is looking a little bit messy, but with this calculation, or I should say blurry, when they're asking the value of A, if you're starting at this angle here and you labeled your sides, A would be the opposite side because it's opposite to the angle. Your hypotenuse is always across from your right angle, and adjacent is one beside. So if I want to find side A, I need to set up a ratio with the side you have and the side you want to know. That's opposite and adjacent. So if you're looking at SOHCAHTOA, which you can write down every time, the ratio that has opposite and adjacent is tan. So if I set my ratio up, then it's tan of my angle, which is 51, will equal the opposite side, which is A, over the adjacent side, which is 14. And then if you needed to solve for A, you would multiply both sides by 14 That cancels, and now A's alone. So A is going to equal 14 times the tan of 51. With this next one, we're doing the same thing. You're starting at angle X. You label your sides. So the opposite side would be across. The longest side across from the right angle is your hypotenuse, and the one beside you is adjacent. If you want to solve for angle X, you need to set up a ratio with two sides you have, and in this case we have the hypotenuse and the adjacent side. So if you look at SOHCAHTOA, the value that, or the ratio that has adjacent and hypotenuse is cosine. So we'd set this up, cosine of your angle X equals your adjacent side, which is root 2, divided by your hypotenuse, which is 3. So when you do this one, again, when you want to solve for an angle, you have to press second. So in your calculator, you would hit second and then cosine. Again, if your calculator automatically opens the bracket, you're good. If not, make sure you're opening one. So you take the root of 2 and divide it by 3. If we do this correctly, we should see that the answer is B. You're going to get 61.9 degrees to the nearest tenth, means just one decimal place. Moving from here, we have our next one where we don't have a picture, we have to come up with the picture. So it says a guy wire to a pole makes an angle of 71.4 degrees with the level ground. So I'm going to start with making this angle with the ground, and is 13.8 feet from the pole at ground level. So if this is where the wire is starting, and I know this isn't the most accurate drawing, but this would be the 71.4 degrees, and the distance between the wire and where the pole is 13.8 feet, and I set up making a right angle triangle. And then the question, how far above the ground is the guy wire attached to the pole? So we're looking for this distance here. So when we want to set up a ratio from the angle we have the opposite side, that's what we want to find. Across from our right angle, you have the hypotenuse, and beside your angle is your adjacent side. So when you're writing out your trig ratio, SOHCAHTOA, if you want to find a side, you have to set a ratio up with the side you have and the side you want to know. So that's opposite and adjacent, which would be tan. So I would set this up, tan of my angle 71.4 equals opposite over adjacent. And I know my adjacent side is 13.8. Now this is like the previous example, but we're now just solving for it. So to get opposite alone, you want to multiply both sides by 13.8. So and then you can put that into your calculator. And when you do that, you will see, I believe this is that your answer is going to be 13.1 feet. So plug that in, 13.8 times tan of 71.4, and we should see 13.1. Moving on to the next one. Oh, I think this is, I'm skipping a question, but that's okay. We'll come back to it. Moving on to this one, you have a man 6 feet tall casts a shadow that's 10.6 feet long. And it's asking about the angle of elevation of the sun. So when you're looking at this one, if you need to draw a triangle no matter what. If the man is 10.6 feet, that would be this side here. So we can say that this guy, just pretend this looks more accurate, is 10.6 feet tall. And then his shadow would be going this way here because the shadow would be on the ground. And the angle of elevation is always from a horizontal line. So we're looking for this angle in here. So we know his shadow was 10.6 feet and he was 6 feet tall. This looks very messy here. I think I put the wrong value, 6 feet. Okay, so if we want to find this angle, label your sides. You have opposite, you have adjacent, and you have hypotenuse. And if we want the angle, we need at least two sides, and we have opposite and adjacent. So that will be the tan ratio. So tan of your angle will equal 6 feet over that 10.6 feet. And we want to solve, so in this one you would do second tan, and then again it's going to open a bracket, and if not, you open one. 6 divided by 10.6. So let's put that into our calculator, and we should see our answer is going to be A, 30 degrees. Okay, so moving on from here, we have this diagram. We have 2 triangles, so we'll probably have to play around with this a little bit. And the first one, if you read this, it's just giving you some information saying that this is a fence for a horse breeder, blah, blah, blah. So number 9 says the length of the fence represented by D to F. So we're solving for this side here. Now, we can't do anything yet because we only have one piece of information for this triangle, which is 55 degrees. Well, I guess we also know that this is 90, but we need a side. So that's why we have this other triangle to the right-hand side here. We can use this triangle to find the side that they share, and then once we have that value, then we can find the missing side that it's asking for. So that's what I'm going to start with and I'm going to start with the angle that was given to me and label my sides. So opposite, this one would be adjacent, and we have hypotenuse. So when you do your ratios, so katoa, when we start at this angle, we have the hypotenuse and we want the adjacent side. So that's going to be cosine. So setting this up, cosine of 43 equals the adjacent side, which we're solving for, over the hypotenuse. So we'll go ahead and put that into our calculator. We're just multiplying that 0.85 up to the other side, so it cancels. And then in your calculator, you will put 0.85 times, and then I need the cosine. Is this going to work for me? Cosine of 43. So I'm getting a small number, and that's good because that makes sense. So my adjacent side equals 0.621, and this value is going to keep going, and that would be in kilometers. So that would be this side right here. So now we can use that information and figure out this missing side that the question is asking for. So from this triangle on the left-hand side, starting at the angle 55, you have the opposite side. This one would be the hypotenuse, and this line that's shared is still the adjacent side. So now I want to set up a ratio with the side I have, which is my adjacent side, and the side I want to know, which is my opposite side. So I'd write tan of my angle 55 equals opposite, which I'm solving for, over adjacent. 621, and that value, hopefully you still have it in your calculator. So to solve for the opposite side, just divide that number in the denominator, or not divide, multiply that number that's in the denominator up to the other side. So now that we have this, we can multiply it by the tan of 55, and with rounding to the nearest hundredth, you'll see the answer is A. Moving on from this one, and it is a continuation question, and I'm sorry that this is cut out over here. I didn't mean for that to happen, but it is continuation, and it is asking you what is the value of the cosine of G. So G is over here, and this one we don't need to really overthink it. If we want the cosine of G, we need to know what the angle of G equals. So we can figure out this angle because all triangles add up to 180. So if we subtract the other two angles, right, and we know this means 90 degrees, we will have angle G. So I actually need to stick that in my calculator. So let's go ahead and do that. And you get that this angle is 47. So now if I want to do the cos of G, I'm just plugging cos of 47 into my calculator. So when you do that, you will see the answer is 0.68, and we can move on from there. So that would be number 10. And then the other part of this is now bringing in area. And I won't waste our time with this one because we should know how to calculate area. And for this first triangle, it would be base, which would be here, times height, which is that side that's shared, divided by 2. And then for this second triangle, it would be base, which would be here, times height, which is here, and this is also divided by 2, and you would add these two values together. So if we were doing that one, we could write that down, plug that into your calculator, and then it says to the nearest, this is another way of just saying to the nearest tenth. So moving on to question 11, we have the length of AC is what we want to calculate, and the length of AC is this total distance. So we're going to have to split this up and look at the first triangle on the left and figure out this missing side, and then we'll do that to the right hand side, figure out this missing side, and add the two together. So let's set up our SOHCAHTOA. And for that first one, I'm starting at angle 57. Opposite is that value 37. Your hypotenuse is here, and your adjacent side is here, and that's what we want to solve for. So when you're trying to find a side, you look at the angle or side you have and the side you want to know. So opposite and adjacent is tan. So setting this up, tan of 57 equals the opposite side over the adjacent side. Now, a quick trick to solve for that adjacent side, instead of multiplying both the a up and then dividing, you can just swap these two. So your adjacent side equals 37 divided by tan of 57. So if you're ready, you can put that into your calculator and get a value. And I'm just doing that right now because I didn't have that one written out. And I'm getting 24.02, and that number will keep going. So now I need to do that for this other side, starting at angle 39. It's still, my opposite side is 37. And this time my adjacent side is also what I want to solve for because my hypotenuse is my longest side. So I'm using the tan ratio one more time. So tan of 39 equals 37 divided by that adjacent side. So same trick, if what you want to know is in the denominator and it's set up this way, you can just swap it, and the adjacent side will equal 37 divided by tan of 39. Of course, if you like all those extra steps, you can do that as well. So let's plug that into our calculator, 37 divided by tan of 39, and we're getting that value 45.69, and this number will continue. So once we're done that, then we're not quite done because now we have to add these two values together. So we can do that, and when you do that with rounding to the nearest meter, we're going to get the answer B because we get 69.7, so that will round up. Okay, so the next one, determining the area of the following triangle. I think this one is worth doing just because we have to visually see that we don't have a right angle. So far we cannot use SOHCAHTOA because this only works if you have a right angle, because that right angle gives us that hypotenuse. So what you can do is split this triangle, sorry, this is supposed to be a line, down, and that will make a right angle. And that's what we need, because if it's asking for area of a triangle is base times height divided by 2. We know the base is 57. This height is the value we don't know, so we want the height, and then we can divide it by 2. So let's go ahead and find that height starting at angle 19. So from angle 19, you have your opposite side. From that right angle we created, you have the hypotenuse, and you still do have your adjacent side, but we won't need it. So when we want to find this opposite side, you want to set up a ratio with the side you have and the side you want to know. So this one's going to be sine. So sine of 19 will equal the opposite side divided by 39. So with this one, because we want the opposite side, we need to multiply 39 to the other side, and then you can plug that into your calculator. The value you get here will go in for h and allow you to solve for the area. So let's go ahead and take a moment to do that. So we'll have 39 times the sine of 19, and then that's going to equal 12.697, and that number will keep going. We want to multiply that by 57 and then divide by 2. And if it's asking to the nearest square centimeter, that's just the nearest whole number, and that would be 362, because we get 361.8, so that would round. Okay, let's keep going here. Our next one, we have another example where we have to be able to visually see it. So if you have an isosceles triangle, that means you have a triangle where two sides are the same. So it's saying A to B equals C to B. So this would be A to B and B to C. These two sides would be the same. It's telling you the area of the triangle is 30, and A to C, this distance here, is 12 degrees. I'm sorry, not degrees, centimeters. Asking the angle of ABC, B is here, we want to figure out this angle. So to do that, we can figure out the height, and if it's an isosceles triangle, then these two, we can essentially split this 12 in half. So this side would equal 6, this side will equal 6. So the part that's missing is this part in here, because if we had that, we can find part of the angle and then multiply it by 2 to find the rest of it. So let's do that. Let's figure out this side first, and that's knowing that area of a triangle is base times height divided by 2. So let's plug in what we know. We know the area is 30. We know your base is 12. You don't know your height. We're dividing by 2. So let's solve for h by multiplying both sides by 2. So we'll have 60 equals 12 times h, divide both sides by 12, oops, and then h will equal 5. So if you know that this value here is 5, now you can set up, and again, we want this whole thing, but since we've cut this into a right angle, then this little bit in here, we can do opposite, which is 6, over adjacent, which is 5. So that would be the tan ratio. So tan of angle B, or half of angle B, equals 6 divided by 5. So let's put that in the calculator. So that reminder, when you want an angle, you must press second. So in your calculator, you would hit second, and that's not going to allow me to do it. So you'd hit second tan, and then 6 divided by 5, and we should get the value 50, that the angle B will equal 50 degrees. But again, from this triangle, that 50 is just half of it. So we want to multiply it by 2, so we get the whole thing. And that will be A, which is 100 degrees. Okay, so moving on, getting closer to the end here, we have another example where you have to fill in some sides. It's telling you have a square, and if there's a square, every single side, so this whole side would equal 12, 12, 12. It also tells you from G to H equals 15, and then it's asking to the nearest degree the difference between angle HGF and angle HDE. So HGF, if I follow H to G to F, is going to be this angle in here. And if I want HDE, so H to D to E would be this angle in here. So the 3 letters tell you which triangle, the middle letter tells you which angle. So looking at SOHCAHTOA, if I look at angle G here first, I would have a right angle. 15 would be my hypotenuse because it's my longest side, and I'm not looking at my opposite side, I'm looking at my adjacent side. So if I want to find angle G, I set up a ratio with the 2 sides I have, which is adjacent and hypotenuse, which is tan. So tan of angle G will equal to adjacent, which is 12, divided by 15. So we'll get that first, and then so just that reminder to do that, you would hit second tan, and then open your bracket, 12 divided by 15. So that's the first one to get the angle for G. And then we are going to figure out angle D. Angle D, we're doing a similar part, but we need another side, and we don't have enough information to just find angle D because we don't have another side. But we do have enough information to find H to F, because with that first triangle we were dealing with, we can figure out F to H and then take it away from 12. And you can do that just using Pythagorean. So we know a squared plus b squared equals c squared. Your longest side is 15 squared. This 12 could go in for either a or b. So let's do that. And in your calculator, take a moment and solve for b. So we'd move that 12 squared to the other side. So we'd have 15 to the power of 2 minus 12 to the power of 2. And that b squared equals 81. Square root both sides. B equals 9. So this part here from H to F is 9. We know this whole length is 12. So then 12 minus 9 is going to be 3, and that's going to be this little bit in here. Now that we know that, we can do the next little bit, which is setting up our next ratio, which is going to be opposite over adjacent, because this is our right angle. This would be the hypotenuse. So your angle here is tan, sorry, I said opposite over adjacent. So tan again, tan of angle D will equal 3 divided by 12. To solve for D, you'd hit second, so I'm just going to write it here, second tan, and do 3 divided by 12. Now, once you have an answer here and an answer here, you're going to subtract it because it's asking for the difference. So we'll do that quickly. Let's plug this all into our calculator, look for that difference, and once you subtract it, you'll see your answer is 23 degrees. So the difference between the two is 23. Okay, moving on from this one, we now have a 3D shape, but we can still do all of the same amount of work. So taking a look and just filling in some information, it's asking, or we're known that it has a vertical height. So from the base of the pyramid to the top, you have a height of 14. It also tells you that you have a midpoint along the line C to D. So this side and this side would be the same length. And angle AKL, so this one in here, is 70 degrees. Now the question, or it's asking for the nearest degree, the measure of angle A, so here to C to K. So what we can find in this is, what can we find? Let's take a look. We could figure out what this shared side is. If we have a vertical height, we also know it's a square. So if you know this distance, we'll know this distance, which will know this distance. Okay, so we're going to use this first triangle inside. I'm just going to redraw it to make it. This is 70 degrees. We want this side and we're going to want this side, and we know this side is 14. So labeling your sides from your angle, you have opposite, adjacent, and hypotenuse. So let's find your adjacent side first, and your adjacent side is going to be setting up a ratio with the side you have and the side you want to know. So we're going to use tan. So tan of angle 70 equals opposite over adjacent. We can use our little trick here to solve. So if you go 14 divided by tan, just doing it one time, of 70, you get this adjacent side equals 5.09, and this number keeps going. So that's the case. That means if this distance is 5.09, then this distance is also 5.09. And our goal is to get this in here, so we'll keep going. Let's also figure out this length, which is the hypotenuse here, because that's shared in the triangle we're looking at. So if I want my hypotenuse, starting from my angle 70, I want a ratio with opposite and hypotenuse, which would be sine. So sine of 70 equals the opposite side over the hypotenuse. Do our little trick, and we get 14 divided by the sine of 70. And that's going to equal your hypotenuse, and that is around 14.898, and that number keeps going. So now looking at the triangle it's asking you about, which is this triangle in here, let's redraw that. So it looks a little bit skinnier. This distance is the same as this one, which is that 5.09. This length for hypotenuse would be this length over here, which is from the right angle, and that's going to be 14.89. And we're going to solve for this angle at C because this is the triangle CAK. So angle C, labeling your sides, we have opposite and we have adjacent. So now we can do the tan ratio, and then tan of your angle C equals the opposite side divided by your adjacent side. So we'll plug that all in, and when we're done, we should see our answer is, let me check here, 71 degrees. We're going to move on. We have number 13. There's a lighthouse window 30 meters above sea level. So I'm assuming we're talking about up here. So let's make our triangle, and this part would be 30. The angle of depression to the two buoys, which are in direct line of sight from the lighthouse, are 15 degrees and 26. To the nearest tenth of a meter, what is the distance between? So if we had two floaty things, so one's here and one's here, we need to draw two triangles. Anytime you're doing angle of depression, it is from a horizontal line. So we have one that it's going to be 15 degrees, which would be the shorter one here, and we have another, which is a little longer, and that's 26 degrees. So that is our beginning part, and what we're trying to find is this distance in here. So let's make two triangles and label what we have. We have 30 here. If I'm looking at this bigger one first, from my angle of depression, if this part is 15, then 90 minus 15, sorry, maybe you can hear my dogs, they're barking outside. 90 minus 15 is 75. This angle would be 75 degrees. So what we can do is find this length and label our sides. So from 75, this would be opposite, the side we want to find. This is your hypotenuse, and we have the adjacent side. So when we're taking a look at this, opposite and adjacent would be tan. So tan of your angle 75 is O divided by 30. So we're going to solve for that, multiply both sides by 30. That will cancel, and we'll find, put that in your calculator, 30 times the tan of 75. And we get this long value right here, from here is 111.96, and this number keeps going. Now we're going to do that again, but looking at the smaller triangle. So if I redrew that smaller triangle, this height is still 30, and the angle of depression was 26. So now if I minus 26 away from 90, I get the angle 64. Now the rest is still the same. I still want to find this side. It's a similar setup. It will be 30 this time times the tan of 64. So I'm skipping a few steps here, but just set up your ratio and solve for this missing side, which is the opposite side. So 30 times tan of 64 is 61.50, and that number keeps going. So now going back to our original drawing, again, we want this distance. What we have found out from this first triangle is from the end to the base of the lighthouse is 111.96. Then from the second triangle's base to the lighthouse, we have 61.50. So if we subtract these, we will be left with that missing amount, which is the distance we want. So go ahead and take a second to do that. 0.96 minus, and we're getting this value 50.5, and that is what we wanted. So just make sure that you're taking your time setting up your ratios. From here, if they're asking for the length of C to D, we're not actually calculating, it's just showing you know how to set up your ratios. So the length of C to D is this whole length here. So using this first triangle, starting at the angle given, we have the opposite side and the adjacent side and the hypotenuse. So having a letter C here is essentially implying we have that side. So if you wanted to figure out the distance between C and E, you need to find your opposite side. So the ratio that would allow you to do that is sine. Sine of x will equal opposite over hypotenuse. So let's set up that. Sine of x equals opposite over C. If you want to get C alone, or opposite alone, multiply both sides by C. So that would give you this distance, this first part. Now we're looking at the second triangle. We still need this part here, but from this angle, we have opposite, adjacent, and hypotenuse. We want the adjacent side, but we have the hypotenuse. So the ratio that combines adjacent and hypotenuse is cosine. Cosine of x will equal that adjacent side, which we want to find, over your hypotenuse, which is d. So you can multiply both sides by d to get a alone. Then if you're solving, so this value will give you this distance. So if you want this total distance, we need to add these two together. And the one that's showing that, I believe, is A. Okay, last one here. If we're finding the length of C to P, given the triangles, what we want to recognize is that from this triangle on the right, did I say C? L to P. We need this side here. But we need a missing side. So what we can do instead is not look at this little triangle, look at the large triangle, add these two angles together, because if we do that, we can still find the side. 92 is your hypotenuse. 20 plus 34 is 54 degrees. We have a right angle, and we can set up our ratio. We have the opposite side. We need to find the adjacent side. So the ratio with the side you have and the side you want to know is going to be cosine. So cosine of 54 will equal adjacent, which we're solving for, over 92. Multiply both sides by 92, and you'll be left with your adjacent side. And so let's go ahead and put that into our calculator. 92 times cosine of 54, and we'll get 54 degrees. There is one more part to this, but it's just calculating a side again. So if you wanted to find this part, we would now use, with this side, we can use this triangle on the right to find this distance. Then we can use the large triangle to find the big distance and then take the difference. If you lasted with me this far, please subscribe if you found this video helpful. And if you have any kind of comment or a video you'd like me to do, just leave me a comment. Thanks for watching.